Hello student, welcome and very good morning to you. Today I will be discussing a DPP on electric field intensity, that is DPP 8 of electrostatic. This DPP will be extremely helpful to those students who are preparing for NEET, main, advanced and WB joint. Please write a comment on this video because this comment will be extremely helpful for me to make the next video for you. First of all, the concept needed to solve these MCQs. Look at this. First of all, the electric field E. First of all, electric field E equal to, this is the force by charge. Its unit is Newton per coulomb or volt per meter. And the electric field due to charge q at a distance r from it, this is the E equal to kq by r square. And due to positive charge electric field is directed away from the charge, and due to negative charge electric field is directed towards the charge. Okay, now look at this numerical. Intensity of electric field required to balance a proton of mass 1.7 into 10 to the power minus 27 kg and charge 1.6 into 10 to the power minus 19 coulomb in a vertical direction. Now look at this, proton has positive charge. So due to gravitational force, the force acting mg in the vertically downward direction. So electric field must acting in upward direction. So vertically upward force, this is the charge of proton into E. As the proton is equilibrium or in balance condition, so here QE equal to mg. So look at this, E equal to, this is the mg by q. Now look at this, m is the 1.7 into 10 to the power minus 27. G is the 10 whole divided by, this is the 1.6 into 10 to the power minus 19. So look at this, this is almost equals to 1 into 10 to the power, this is the minus 7. This is the volt per meter or Newton per coulomb. Look at this, this is the 10 to the power minus 7 volt per meter. Okay, understood? Next. Now question number 2. The intensity of electric field required to keep the water drop of radius 0.5 centimeter just suspended in air when charged with one electron is approximately. Okay, so look at this here. So look at this here, mass mg is directed vertically downward, and this mass mg equal to, this is the 4/3 pi small r cube into rho into z. And look at this here, charge is negative, so electric field must directed in downward direction. Therefore, force is directed in upward direction, and this is the QE. Okay, so look at this here, QE equal to, this is the 4/3 pi r cube into rho into g. Therefore, E equal to, look at this here, pi and 3 are roughly, look at this here, 3 and pi are roughly cancelled out. So E equal to, this is the 4 r cube. R cube means, look at this is the radius 10 to the power minus 5, that is 10 to the power minus 7 meter whole cube. So this is the 10 to the power minus 21. Okay, so look at this is the 10 to the power minus 21. Rho, this is the 1000. G, this is the 10 whole divided by, this is the 1.6 into 10 to the power, look at this is the minus 19. Okay. So look at this here, 10 to the power minus 19 and 10 to the power minus 21. So look at this. This is the 10 to the power minus 2. 10 to the power minus 2 into 10 to the power 4. So this is the 100. So here look at this, 400 by 1.6. So this equal to roughly 250 or 260. So look at this. This is the 260 Newton per coulomb. Okay. Understood? Next. Now, question number 3. A charged water drop whose radius is zero point 0.1 micrometer is in equilibrium in an electric field. If the charge on it is equal to charge of an electron, the intensity of the electric field. Look at this, the intensity of the electric field E. So force is the QE, as the water drop is balanced or in equilibrium. So QE equal to mg. No problem. Now E equal to, look at this, E equal to, this is the mg by q. Look at this, m is the 10 to the power. Look at this. Here radius is equal to 10 to the power minus 7 meter. Okay. As radius 10 to the power minus 7 meter, so r cube equal to 10 to the power 10 to the power minus 21 meter cube. No problem. So look at this, mg is the 4 third pi r cube. R cube means 10 to the power minus 21. This is the rho, so this is the 1000 and g is the 10. Okay, whole divide by, look at this. This is the 1.6 into 10 to the power minus 19 coulomb. So look at this, pi and 3 almost cancel out. Okay, look at this, 10 to the power minus 21 and 10 to the power minus 19. So 10 to the power minus 2. And this is the 10 to the power 4. So this is the 100. So this is roughly 400 by 1.6. This equals to, this is the almost 262 Newton per coulomb. Okay, understood. Next. Now question number 4. A point charge of 20 microcoulomb and 80 microcoulomb are 10 centimeter apart. Where will be the electric field strength be 0 on line joining the charges from 20 microcoulomb? Look at this. This is the figure. This is the 20 microcoulomb and this is the 80 microcoulomb. Distance of separation 0.1 meter. As these two charges are like charges, so electric field becomes 0 between a point. Electric field will be 0 at a point between the two charges. So look at this. Suppose this is the point where electric field is the 0, and distance of this point from this charge is the x. So distance of this point from 80 microcoulomb charge, this is the 0.1 minus x meter. No problem. Look at this. Due to this charge, electric field is directed along this direction. And due to this charge, electric field directed along this direction. Okay. So look at this here. K into 20 microcoulomb divided by x square. This equals to K into 80 microcoulomb divided by 0.1 minus x whole square. No problem. Look at this, microcoulomb cancel out. Okay. K cancel out. 20 to 1, 21 and 80. This is the 4. Therefore, 1 by x whole square. This equal to 2 by, this is the 0.1 minus x whole square. No problem. Therefore, look at this here, 1 by x equals to 2 by 0.1 minus x. So look at this here, twice x equals to 0.1 minus x. Therefore, 3x equals to 0.1. Therefore, x equals to, this is the 0.1 divided by 3. So look at this is the 0.033 meter. Option C is correct. Okay. Question number 5. A charged particle is suspended in equilibrium in a uniform vertical electric field of intensity. This is the 2 into 10 to the power 4 volt per meter. If the mass of the particle is 9.6 into 10 to the power minus 16 kg, the charge on it and axis number of electron on the particle are respectively. Okay, so look at this as it is in equilibrium. So here QE equal to mg. So here Q equal to, this is the mg by E. Look at this here, m equal to, look at this here, m equal to 9.6 into 10 to the power minus 16. And G is the 10. And electric field, this is the 2 into 10 to the power 4. Okay. So look at this. This is the 9.6 into 10 to the power minus 19 by 2. That is 4.8. So axis, so this becomes 3 into 1.6 into 10 to the power minus 9. So axis number of electron is the 3. So look at this. Charge is the 4.8 into 10 to the power minus 19 coulomb, and axis number of electron here, this is the 3. Okay, understood? Many thanks for watching this video. This video will be extremely helpful to you for your preparation in NEET, Main, Advanced and West Bengal Joint. Okay, thank you.